All right, so here's our lesson on absolute value functions and transformations. I just want you to be aware that transformations is something that's going to be super important going forward in this class and all throughout Algebra 2. So today we're going to set a pretty strong foundation for the rest of your high school math career. All right, so absolute value functions are defined by a piecewise function. When we talk about absolute value, it looks like these two bars right here. You can kind of think about it like it being jail. All right, so when we look at absolute value, it is a piecewise function, and remember we look at our domain first. So if I graph these points, and I'll just go ahead and kind of give a rough sketch. If I graph x, that means I start at 0 and I go up 1 over 1. So if you're looking at what I'm doing on the graph, down 1, backwards 1. All right, and then that is for x is greater than or equal to 0. So that means I'm going to have a closed line, and I'm going to go on the positive side, greater than. All right, for my second one, I'm still going to start at 0, but this time I'm going to use a negative slope, which is down 1 to the left 1, up 1, or sorry, down 1 to the right and up 1 to the left. And that is for x values that are less than 0. So that's going to be an open circle, and x values that are less, which means we're going to go this way. So you should notice then that our final graph is this V-shaped graph. Okay, so a few different things that you need to note. The parent function is V-shaped, and the way I always remember that is that it's absolute value, right? You got the V in there. And then there's a few different important points to it. This point down here on the bottom is called the vertex. And then you'll notice that this kind of has a mirroring slope on either side, and we'll talk about that here in a minute. So those are the basics that you need to know for absolute value. Let's look at how the transformations apply. All right, so remember when we talk about linear is like a straight line, right? And we've got this parent function, y equals x, which has a regular slope of 1 and a y-intercept of 0. Remember, we did like 1x plus 0. So when we talk about transformations, we talk about what is different. And we've said the negative reflects, or in your case, you tend to think of it as having a negative slope. The 1/2 is going to make it less steep, right? Because 1/2 is less than 1. So this is going to make it less steep. And then the 3 moved it, it was a shift up 3, right? Because it's going to start at a higher y-intercept. Absolute value is very similar, except now I have a V-shaped graph, and our numbers are going to do very similar things. So the negative is still going to reflect, which means instead of my V opening upwards, my V is going to open down. This 3 is bigger than a slope of 1, so that's going to make it steeper. And now this is what's a little bit different. On linear, we only have the y-intercept that we ever think about, right? We just care about where it's going to hit the y-axis. But in absolute value, we've got this vertex point, and think a y-intercept can only move, if you think about a y-intercept, it can only move up or down. Well, in absolute value, a vertex can move up and down, but it can also move to the left and to the right because it could be anywhere on the graph. It's not stuck to the y-axis, which means, and this is the part that's super important for today, so make sure you're listening.
Okay, so just so you have a point of reference for this lesson, I just want to go ahead and show you a dance because I am the best dancer that you've ever seen. This dance is going to help you with transformations and understand just how to grasp some things a little bit more simply for now and for Algebra 2. So the dance that you need to know, you're going to put your hands right here. It's like parentheses, right? So on the inside, we shake our head left to right. On the outside, we go up and down. Inside, left to right. Outside, up and down. And what that's going to tell you is that on the inside, all right, you want to think about it. First of all, you're shaking your head left to right, so that's the direction that's going to move you. And you're saying no. So on the inside, we're going to think opposite. On the outside, you're moving your head up and down. So that's going to be Y. You're going to be moving up or down. And you're going to be thinking the same because you're telling yourself yes. So inside's opposite, left to right. outside the same, up and down. So now that we have that dance down, let's think about how that's going to impact our vertex here, since we're naming a vertex and not just a y-intercept this time. So on the inside, and what we mean by that is on the inside of whatever grouping symbol you have. In this case, we're talking about the absolute value bars. So on the inside of the absolute value bars, we are supposed to think opposite. So that +2, x +2 makes me think -2. On the outside, I'm supposed to think the same. So outside of the absolute value bars in the end there is that +4. So it's going to stay the same, a +4. Now, you can determine the left, right, up, and down without having to name the vertex, but from my experience, people do better when they name the vertex first. So now, if I think about my directions, inside that +2 was left and right. And you all know if you plot this point, -2, 4, you know how to plot that point, right? Think about which two directions are you shifting the vertex. You're shifting it left because you're going -2, and then up because you're going up to +4. So those are the transformations you would name for that absolute value function. The reflection, more steep, a shift left of 2, and a shift up 4. All right, so let's look at how to graph these. The easiest thing to do, and where we have to start, is that vertex. All right, your vertex is your turning point, and that's where you have to start. So the vertex is going to come from these two shifts. And remember, inside is opposite, outside is the same. So that means my inside vertex, inside opposite, that's going to be -1 or left 1. Outside is the same, +4. All right, so I'm going to start by plotting that point. -1, +4. If it'll let me. There we go. And then the number in the front, remember, that's a slope, so to speak. So the negative is going to make it open down or reflect so that it opens as a downward V. And then the slope is 2. So I'm going to count down 2 to the right 1. Now, this is a V, which means I've got to have a matching point on the other side. So that's also down 2 and to the left 1. We can do that a few more times to get a good V-looking shape. Down 2 and to the left 1. All right, which is going to give me this graph right here. Now, the last part that we need to talk about is the domain and range, which is something we haven't talked about. Well, we talk about it a little bit, but we haven't found it in a while. So domain are our x values, and if you think about it, this is really going to end up affecting the entire x-axis. So our domain, and this is usually true, our domain is always going to be all real numbers. And then our range, this is what's a little bit different. Our range are our y values. So when I pick the range, I want to think about what part of the y values am I using? Well, to me, the highest y value is 4, and then I can use all of these negative y values because it's going down forever. So that means I'm going to have a range of y less than or equal to 4. Now, the quickest way, if I am honest with you and I give you like a little shortcut to think about that, the quickest way to get that is to look at the y value from the vertex and use it. And then this is less than because it's opening down. So if the y value had been 7 and we were doing, the slope was positive in the beginning, then this might be y was greater than or equal to 7. All right, let's do the second one over here real quick. So again, I'm going to start with my vertex, which means my vertex is going to be at inside's opposite, so +2, outside's the same, +3, so 2, 3. This time, it says this should be less steep, so I'm going to make a slope of 1/3, so rise 1, run 3, rise 1, run 3. And remember, we have to have matching points on the other side. And you should notice you've got this really wide V on this side. It's still a V shape, it's just really, really wide. It shouldn't be as steep, right? And so when we go to name our points, we've got domain, always all real numbers. Range, remember the shortcut. Pull the y value from the vertex. So that's y, and then I'm going to use the number 3. And because this is opening up,
this time it's going to be greater than or equal to 3. All right, let's look at an example where we actually have to write the equation. And so remember, in those equations, they all appear to be set up the same. There's a number in the front, which is the slope, and then I've got the 2 bars, and then these other 2 pieces of information are from the vertex. So really we need to figure out what's the vertex and what's the slope. So if I look at my graph here, the vertex is this turning point, and my graph is counting by 2. So let's see, that's 1, 2, 1, 2, 3. All right, so my vertex is at 2, 3. And then my slope, if I find all my new points, it looks like that's up 1 over 1. Looks like I have a slope of positive 1. So because my slope is 1, if I go to plug all that information in, I've got a slope of 1. Inside is opposite, so since this is positive 2, I'm going to write x minus 2. And then outside is the same, so plus 3. Which means the simplest way you would see this equation written would be y equals x minus 2, the absolute value, plus 3. Now I will tell you, anytime you write these absolute value bars, you probably either need to make them really bold or just really, really tall, because you need to know that they're absolute value bars and that they aren't ones. All right, there you go. That's all we got for today. We will work on this tomorrow and keep working on piecewise functions tomorrow.